Hi, in the previous class we looked into arithmetic progression AP, and in it we said a lot and we equally made a class explanatory. Now I want us to look into geometric progression GP. Like I said, the next class will be geometric progression. Please, if you've not subscribed to this channel, please do me a favor and do that. Now, what is geometric progression? From what I've written here, a geometric progression, also known as exponential sequence, is a sequence in which any two consecutive terms differ by a constant multiple or factor. Now, that constant multiple or factor is simply the common ratio, designated by R. We all know both AP and GP has first term designated by A. Let's look into example to help us understand what GP is. Sometimes it's difficult to identify the one that is GP and the one that is AP. But remember, in the previous class I made us to understand that arithmetic progression increases either with addition or subtraction. But here, geometric progression, it increases either by multiplication or division. Now let's see example so that we will understand more better what I mean. Let's call this example 1. Let's say we are given 6, 18, 54, 162, so on and so forth as a sequence. And you know, in every sequence you have to first locate the first term, which is already here. This is the first term. Let's say A is 6. This is the first term from the previous class. Remember, first term. Now another thing to locate in that arithmetic progression we did last time. Remember, I told you that its own is common difference designated by D. But in this case, we are no longer talking about common difference. We are talking about common ratio, because this one is increasing either by multiplication or division. Now, how are we going to know what this one is increasing with? The way we do it is, this is the first term. This is the one that follows immediately after it calls second term. This is the third term, fourth term, so on and so forth. Now, the way you do this is, if you say 18 divided by 6, 3. That is how you get the common ratio. You divide the second term by the first term, or you divide the third term by the second term. Any one you want to choose, you divide with the one immediately before it. Now, this gives us common ratio as 3. Now, you see, this is the way you get what is needed. I'm actually going to give you the general formula used in solving this, but it is good you understand how they are done so that you will know how to go about the formula. Now, this R is called the common ratio. Okay, let's do another one. Let's say we have 16, 24, 36, 54, 81, so on and so forth. Now, it's obvious that the first term for this one is 16. Then common ratio, just the same way I've taught you. You can, okay, let's not choose 24 this time. Let's choose 36. 36 divided by 24, we are going to have one whole number, 1 over 2. This is the common ratio. We write it 1 whole number, 1 over 2. Let's do one more example. Let's say number 3. Let's say we have 20 minus 10, 5 minus 2 whole number, 1 over 2. 1 whole number, 1 over 4. So on and so forth. Now, how do we know? We already know that first term is 20. First term is not hard to locate unless this first term is missing. When it is missing, know that you are not given first term. You are either asked to find it or whatever they choose. Now, what is now the common ratio? Common ratio, like I taught you, you equally do anyone you choose. If you like, you choose this. If you like, you choose this. But anyone you choose, use the one before it to divide it. Let's say we choose 5 divided by minus 10. Remember, you must put the sign. What is this giving us? 5 go here, 1. 5 go here, we are having 2. We are having minus 1 over 2. This is the common ratio, minus 1 over 2. We use this example to help us understand how to get the first term and the common ratio for geometric progression. Let's now put it into work. There is something very important we need to talk about now, having known this A and this R common ratio. What is that we have to talk about? The n term. What is the n term of a geometric progression? Let's say n term, which is Gn. N term of a geometric progression is given by this formula. First term multiplied by common ratio to the power n minus 1. This is n. We already know A is the first term, R is the common ratio, then n is the term we are talking about, as in that particular term we are tackling. We will understand more better as we continue. Okay, let me write it out again. Don't look at it as waste of time. I just feel like to write it out. Okay, this is just the formula we need to tackle any geometric progression problem. Now let's go into solving problem. Please remember, this is one of the formula you have to memorize. You have to have it offhand. Let's go into solving problems. It will help us understand more better. Let's say we are given this calculation. Let's call it number 1. They said given 6, 18, 54, 162, so on and so forth. Find the 10th term of the GP and also the 6th term. Now solution. At least this will help us understand more better. We all know from what they've given us, first term is 6. Now what is the common ratio? Common ratio, you do it the way I taught you, 18 divided by 6. 3 is the common ratio. With this, if you're able to get the first term and get the common ratio, I don't think any other thing will be a problem unless you don't know how to follow it. The only thing is, remember the general formula. Remember the general formula of a GP says A common ratio to power n minus 1. Now with this, they are asking us, the first one A, they are asking us 10 term. T10 is now going to be, this is 10, first term is 6 multiplied by that common ratio which is R. You know this n is that term we are talking about, which will now be 10 minus 1. This will now be 6 multiplied by 3 to power 9. Now what is this going to give us? Let's take it gradually. This is 3 to power 9, 19,683. This is 3, please. Okay, this gives us what? 6 times this number. We are having 118098. This becomes the answer. Okay, the above is the 10th term. Remember, they equally ask us the 6th term, which means let's solve for the 6th term. Remember, it's still the same thing, 6 multiplied by common ratio 3. Now it's going to be 6 minus 1, which is equal to 6 multiplied, please, this is 6. 6 multiplied by 3 to power 5. What are we having? This becomes 6 multiplied 3 to power 5 to 243. 243. If we multiply the 2, what are we having? We are having 1,458. This is the answer for this one. We've gotten the 2. They didn't ask us what is the sum of the 2. And even they said the sum of the 2, we add this one and this one together. Okay, let's quickly go into another problem. Let's say we have this problem as the second one. They said the 8th term of a GP is 640. If the first term is 5, find the common ratio and the 20th term. Let's solve. Solution. They said the 8th term, which is T8, is 640. And remember, the 8th term should be, according to the formula, 8 minus 1, which is equals to A power 7. And they said this is 640. Given first term A to be equal to 5, this is going to help us. We will put it here. We are now going to have, let me write it out first. 640 will now give us 5 multiplied by R to power 7 is equals to 640. We divide both sides by 5. Divide both sides by 5. 5 cancel 5. We are now going to have R with it power 7. Will now give us, if you divide these two, we will have 128. This 7 need to be removed. This power 7 need to be removed so that R will stand on its own. Now what are we going to do? We do the 7th root of both sides. 7th root of both sides. 7. Now this 7 will cancel this 7th root to leave R alone. If we now do the 7th root of this one, we are going to have it to give us 2. Gotten our R as 2. Let's go back to the question and check something. If we go back to the question, what are they saying? If the first term is 5, find the common ratio and the 20th term. Now we've gotten the common ratio, which is R. They are equally asking us to get the 20th term. 20th term, which is T20, is going to be, we all know our first term is 5, multiplied by that R is now 2 to power 20 minus 1, because that's the term we are talking about now. This gives us 5 multiplied by 20 to power 19. Now we'll continue. This equals to 5 times 20 to the power 19 is going to give us 524,228. Let me write it. 24,228. Now we'll multiply the 2. 5 multiplied by this. What is it going to give us? Give us 2621440. This is the answer, which is 2,621,440. Please do yourself a favor to consult one textbook or the other. Even you can search online to know more and solve more problems on this geometric progression. Also, equally watch that of arithmetic progression. Please don't forget to subscribe. I want us to go to series. Series is very important. It will be the conclusion of this sequence and series. Let's go to it. Series. Now let's understand this series. From what I wrote here, when the terms of a sequence are added, the resulting expression is called series. When you add the whole sequence given to you together, the answer you get becomes the series, as in it has to do with the sum of the whole sequence, the whole terms that appeared in a sequence. Now let's use an example to explain it more better. I believe we will make it more clearer there. So let's begin with A. Let's say we are given 1 plus 2 plus 3 plus 4 plus 5 plus so on and so forth. Now, if you check, when we are talking about sequence, we are using comma. But in this series, we are now using plus. Why? Because series is all about summing of the whole terms given in a sequence. Now let's talk about another example, because we are still going to look into a proper problem. Let's just introduce this. Let's just make us understand this series, what they are talking about. Now, let's say we have 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus so on and so forth. You see, this one is equally a series. If you add this, we don't know where they are asking us to stop. We'll look into that in a problem, maybe with another one. Let's say, see example, let's say we have 1 plus 4 plus 9 plus 16 plus 25 plus so on and so forth. Now, I wrote this just to help us understand that series is about addition of the whole terms that appear in a sequence. Now, there is something very important. Series has general formula for both arithmetic progression and geometric progression. Let's look into them. Okay, the sum of arithmetic progression, series. Okay, let's use Sn to represent it as the sum of an arithmetic progression. Now the formula says n over 2 square bracket open 2a plus bracket open n minus 1 bracket closes common difference. Remember, this is for AP. Common difference is back. So carry its assignment on. Okay, where S is equal to the sum of AP. Remember, this sum is series. A, we know is first term. D, we know is common difference. N is the term. Now let's go into solving example. It will help us understand more better. Example says, find the sum of the first 20 terms of the arithmetic progression. 16 plus 9 plus 2 plus minus 5 plus so on and so forth. Solution. They've given us first term, and you know you can equally get common difference from this array of numbers. Let's say first term is here, is 16 here, common difference is what? 9 minus 16. What are we having? It will give us minus 7. See the common difference. Now you go into solving. Remember that formula says sum of arithmetic progression equals to n over 2 square bracket open 2a plus bracket open n minus 1, then common difference comes. The square bracket closes. Now let's solve. Remember they said find the sum of the first 20, which means this is going to be the sum of the first 20. That's what we are talking about, 20. You see where I put it? This is now going to be 20 over 2 square bracket open 2 bracket first term is 16, very important, plus bracket open that 20 comes in because that's the term we're talking about, 1, then common difference we know is minus 7. Okay, the square bracket comes again. Now solve. This is obviously 10 because 20 divided by 2 is 10. Now this comes, this time this is giving us 32, plus we all know this will give us 19 multiplied by minus 7, curly bracket. This becomes equal to 10 curly bracket open, 32 comes, plus this 2 will give us minus 133, curly bracket comes. Now this gives us 10, 32 plus times minus becomes minus 133, curly bracket comes, 10. These 2 will now give us what? Minus 101 when you do the subtraction. Now we multiply 10 multiply this, we're having minus 1010. This is the answer. Now this is for arithmetic progression, the sum of arithmetic progression. That of geometric progression has its own sum of geometric progression. Let's look into it. The sum of geometric progression has 2 formulas. What are they? The first one is this. Let's say S1 equals to A bracket open 1 minus r to the power n all over bracket open 1 minus r. But this one, you can only use it for r less than 1, where common ratio is less than 1. Now let's see the other one. The other one is saying first term r to the power n minus 1 bracket closes all over bracket open r minus 1 bracket closes. This one is for when common ratio is greater than 1. I know it might confuse you as I've written it, but let's go into solving problem. It will explain it more better. Okay, we are given this example that says find the sum of the following GP. A, 2 plus 6 plus 18 plus 54 plus so on and so forth until 1458. Now B says 30 plus 15 plus 7 whole number 1 over 2 plus 3 whole number 3 over 4 plus so on and so forth as far as 8 terms. This B, they are telling us to get it up to 8 terms, the sum up to 8 terms. But this one, they've summed this A, they've summed and they've come to achieving this total sum. But the problem is that we don't know what term it is. We don't know if it is 6, we don't know if it is 8, we don't know if it is 9, but they've concluded their own and they are giving us this sum. Now, how do you solve this problem? Let's see. Okay. We know first term is giving us 2 from that A. What of common ratio? Common ratio is, you can say 6 divided by 2 or 18 divided by 6, which will give us 3. Now, we know that this R is greater than 1. Since it is greater than 1, the sum of GP we are going to use will be this one, r to the power n all over. But there is a problem here. We can't be able to solve this. Why? Because we don't know the term this is. Look at, they gave us first term, second term, third term, fourth term. They came here, they jumped certain number of terms and gave us the final sum they want. What are we going to do? We need to decode it. We need to know what it is. How do we know it? We can actually use it to know the term this is. Since they've given us the total sum, it can be a help. What do I mean? Recall, general formula for geometric progression, no longer the sum now I'm talking about. I'm talking about the geometric progression. It says first term multiplied by common ratio to power n minus 1. Okay, let's say this is equals to that total sum. We don't know the term, but we know its value of a particular term we don't know. That's why we are bringing this, so that we know the term. Since we know the first term, we know the common ratio, we can get the term. Hope you are following what I'm doing. You have to use your numbers, it's your common sense, if I must use the word. Now, A is 2, common ratio is what? 3. Now, we don't know this n. We write it. This, we'll repeat this one. We want to get what n is. Let's begin by dividing both sides by 2. This one divided by 2. 2 cancel 2 here. 3 to the power n minus 1 comes out. This 1458 divided by 2 is going to give us 729. Now, we still need to remove whatever that is still disturbing this n so that n can stand out alone. Now, what are we going to do? This brings us to indices. Remember, this 729, we will look for what we will do to make it to become something 3 to the power something, so that we can cancel out. What are we going to do? Let's repeat this one. This 729 is the same thing as 3 to the power 6. If it is 3 to the power 6, you can multiply it 3 times 3 times 3 up to 6 times, to give you the same. Which means 3 can cancel this 3. N minus 1 will come out, we'll have 6. Now, we will make n the subject of the formula, which will be 6. If this minus comes to this other side of the equator, the sign will change. N is now becoming 7. Hope you understood what we did here. Now, n is now 7. We can now use 7 to solve problem. First of all, let's still write out what is given to us. They gave us A as 2 above there. They gave us common ratio as 3. We've now gotten n to be 7. N. The problem is almost getting solved. Remember, because r is greater than 1, we are using the sum that says A bracket r to the power n minus 1 all over r minus 1. Okay, now we can easily say let this be the sum of geometric progression to the 7th term. So first term is 2, bracket open, common ratio is 3. We now put 7 here, minus 1 all over 3 minus 1. Okay, if we break this, what are we having? We are having 2, bracket open, 3 to the power 7 is going to give us 2187 minus 1 all over 2. Now this 2 can cancel this 2. This sum to 7 times comes down. We're now having 2187 minus 1 will give us 2186. This becomes the answer we are looking for. Please, you can go back to this problem and check from beginning so that you understand how we are solving it. Let's look into the question B. Let's go back to the question. The question gave us 30 plus 15, so on and so forth. But they are saying that we should sum it as far as 8 times. This one is simple. We just bring in 8 times straight and use it to solve. Now we are talking about B. Remember, the first term there is 30. Common ratio is equal to 15 divided by 30. Remember, it will be 1 over 2. And this one, they gave us this. They are telling us to solve to as far as 8 terms, which means n is 8. Now, if you check this common ratio, which is 1 over 2, the common ratio is less than 1, which means the formula we are going to use will be the one that says first term 1 minus r to the power n all over 1 minus r. Therefore, sum to 8 terms is going to be, first term is 30, 1 minus common ratio is 1 over 2. Remember, is the n power is for all of them, 8 all over 1 minus common ratio 1 over 2. Go ahead and solve. Let me gradually take this so that you will understand how it is solved. Let's write 30, bracket 1 minus. This whole thing is the same thing as 1 to the power 8 all over 2 to the power 8. Hope you understand. This 8 is for 2 of them. I don't just want to rush and solve everything and give you answer. No. This class is for the purpose of your understanding. Now let's repeat this. Let's take it gradually. Yes, it might take time, but if you can know how to do it, it's my interest. Sum to 8 terms will now become 30, bracket open, 1 minus 1 to the power anything is still 1 all over 2 to the power 8 is going to give us 256. Okay, all over. Let's go straight by looking for the LCM. This one, LCM of 2, and you can say let this be over 1 if you like, or you can substitute. LCM is 2. How we do LCM is, if you get the LCM of the 2 denominators, now use the denominators to divide the LCM you got, then use the answer to multiply the numerator. Now let's go ahead. This 2 divided by this 1 will still be 2. We use the 2 it gives, multiply this 1. See how we do that negative compound. This 2 divided by this 2, which is the denominator, will give us 1. That one multiplied by this 1 will give us 1. Hope you are following me. Let's go ahead. 30, bracket open. LCM also of these 2 gives us 256, because this one is 1. it will still be the same thing. Okay, 256 divided by 1, it will still be 256 times this one, it will be 256. 256 divided by 256, 1 times this one, it will be 1 all over. This one is 2 minus 1 is all over 2. Okay, this is the same thing as, let me take it gradually, let me not speed up then. This minus 1 will give us 255 all over 256. Now this division, let's repeat this, bracket 255 all over 256. Now if I change this division to multiplication, this will have inverse, it will now be 2 over 1. Hope you are following me. This 2 will now multiply this 30, it will now give us 60 bracket open 255 all over 256. This becomes equals to 60 times this one will give us 15,300 all over 256. Now if we divide this into, it will give us 59 whole number 196 over 256. If you like, you can still break it down to 59. This 196 divided by 4, you have 49 all over. This one divided by 4, you have 64. This is equally the answer. Anyone you like. Maybe what we've done here is a bit confusing. Feel free to go back and watch the video, and it's not must you follow your own solving this way. There are many ways to solve this problem, to solve to this answer. There are many ways. You can, if you are allowed to use calculator, you can use your calculator to express them out and get your answer. You might even get your answer to 59 point something as a decimal fraction. This one is just a mixed fraction. Now, I thank you for being a part of this class. Please do share and help a brother out there or a sister out there to watch and learn. Please feel free to consult textbook to do more examples so that you will perfect sequence and series, because this is where we are ending sequence and series. If you have any question, feel free to drop the question for me. By God's grace, I will attend it unless I'm that busy. Okay, thank you. Please don't forget to subscribe, don't forget to share, or equally hit the notification bell so that you always know when we release video. Thank you for being part of this class. I love you.